Okay. So discrete is individual xy points. They look like dots. I'll give you an example in a second, but first let's write down what continuous means. Continuous is when those points or those dots are connected. In one continuous line. I know that it's not really kosher to write continuous in a definition of continuous, but and then I want to write that the line can curve or change direction even as long as there isn't a break. How's my handwriting? Can you read it? Mostly? Okay, so let's do an example of discrete. Let's say you have a friend and your friend has kittens. It's a common occurrence, right, on a farm?
How many of these are we doing? Like, can I just use like one of the whole graph thingies too?
Yep, one example of each. All right, so let's say you have some kittens, or your friend has some kittens, and they are selling their kittens. And they're gonna sell them for, I don't know. I mean, normally I would say if you're giving, if it's kittens in the country, you're probably giving them away, right? But let's say that we're not giving away. Let's say we're selling them. How much are we gonna sell these kittens for?
$20 a pop.
$20 a pop. Whoa. Or maybe just give somebody 20 bucks if they'll take a cat, right? Anyway, so, but we'll say it's $20 a cat. Okay, so we're gonna write over here price, and the price is in dollars. 1 kitten, 2 kitten, 3 kittens. Can you tell me what the scale is gonna have to be on the side here? What am I gonna have to go up to?
20.
Well, it's 20 for each kitten, right? So I'm gonna have to go up to 60, so maybe we'll go by tens.
10.
Remember, this one going up and down is our y, this one's the x. So, if I buy 1 kitten, it'll cost me 20 bucks. But if I buy 2 kittens, it'll cost 40, and 3 kittens is 60. How much does 0 kittens cost?
$0.
$0. Okay, now for a prize, I need somebody to raise their hand and tell me this. Why does it not make sense to connect these dots? Why should I leave these dots just sitting by themselves and not connect them? Why do they need to remain discrete? Okay, discrete is just dots. Continuous is when I connect them. I'm just going to leave them alone. 1, 2, 3, 4, 5, 6,
What about me? Did you
7.
say that was
Are
3?
you raising your hand?
Yeah.
8.
Was that 3?
I think so, yeah.
Oh, my phone. Where'd it go?
2. All right.
You can't have half a cat and pay half price.
Right, yep. You're not going to split a cat in two and say, I'll just pay $10 for this cat, this half a cat, okay? You're not going to just take the tail and say, look, I'll just give you $2 for the tail, okay? Like, that's not something we are going to do. I know you could. I know a crazy person could, so nobody fight me on this, because in your brain right now, you're going, well, technically, stop it. Okay? Stop it. We're not decapitating cats. Hey, Colin, why do you have that many rulers? For fun? I think I've made it clear in this class that this is not a fun place. Okay.
I really don't have
And
a
I'm not even using one.
Hey,
Any of
why
them.
aren't you dressed up?
I just sketched it anyway.
Why aren't you dressed up?
No.
Anybody else doing the same thing?
It's a
No, I have
dress-up
one.
day, come on,
Okay.
step it up.
So, does everybody understand, indeed, Grace, you're right, why this is discrete, why there's just dots, why we can't do anything else? All right, so that's an example of discrete. Grace, go get a prize. And I want her to sign if you'd like one. I've also got fortune cards out today and dinosaurs. You got it. There you go. All right, and then we're going to do an example of continuous. Is anybody in here lucky enough to have a pool at their house?
Tyler.
That's awesome. How long does it take you to fill your pool?
Mine never gets drained.
What?
Mine's an indoor pool.
Oh, shut up, Sawyer. That's awesome.
No, it's been the same for like 10 years.
That is awesome. Go on.
We just let it freeze over winter.
Do you really? Wow.
We did drain it a little, but let it freeze.
My goodness. I didn't know you could do that. I also have never owned a pool, obviously. Okay, so like, somebody could be like, yeah, no mansions you set on fire every year, and I'd be like, really? You know, like, I have no idea. All right, so anyway, so let's say that we're filling a pool, and we're gonna say that it fills about 60 gallons every 5 minutes. Okay? So I'm gonna start making marks down here. This is time down here that I'm measuring in minutes. This is 5, 10, 15, 20. We'll go to 25. Over here, I think I'm gonna go by hundreds. And over here is like the water, and I'm measuring that in gallons. You guys see how I always put what I'm measuring it in parentheses? All right, so what did I say? I said that after 5 minutes there was 60 gallons in there, right? So 5 minutes is 60 gallons. How much is in there after 10 minutes? 120. 3 times 60 is 180, so that's at 15 minutes. 4 times 60?
240.
240, just saying 180 every time?
I said 140,
Oh, okay,
but I meant 240.
got it. What's 5 times 60?
300.
300.
Good job, Colin.
Oh.
And at 0 minutes, there's 0 gallons in there because we're putting gallons in. And this time, I'm going to connect them. Now, the last one was discrete. Obviously, this one is continuous, which means that it is connected through the dots. Remember, a connected graph can curve, it can turn a completely different direction as long as there's not a break in it at all. I need somebody to raise their hand and explain to me why this example is a continuous example, why I should be connecting them and not just having dots.